My dear student, I am A.K. HAZRA from Salt Lake City, Kolkata. I wholeheartedly welcome you to School of Fundamental Sciences for our confidence building program. This intensive program will help you a lot to understand the fundamental concepts of physics, chemistry, mathematics steadily. I earnestly request you to study the content of our videos very carefully. I will be happy if you understand and enjoy the useful concepts. My heartfelt wishes for your bright future. Thank you. My dear student, let us start concept of mole fraction. Now we are defining mole fraction. You see, let the amounts of non-reacting gases, suppose A and B, and more than 2 also, non-reacting, be careful, contains Na number of moles of A, Nb number of moles of B. Then how to define their mole fraction? The mole fraction is defined as XA. Notation actually chi A, but we can write X. We can say XA also. XA is the mole fraction of A equals to what? Just fraction. So number of moles of A divided by total number of moles. So Na plus Nb dot. Similarly, mole fraction of B is what? The amount of B, that is the number of moles of B divided by total number of moles of gaseous mixture. That is, you can say XA, mole fraction of A equals to number of moles of A by N total number of moles of mixture. Mole fraction of B equals to number of moles of B, or you can say amount of B by total number of moles of the mixture. So in general term we can say for a gaseous species S in the mixture, the mole fraction of the species S will be equals to what? XS equals to what? NS, the number of moles of S divided by total number of moles of the mixture. Now associated result 1, we can establish that the mole fraction of A plus mole fraction of B total plus mole fraction of C, D and so on will be always equals to 1. We will explain. Similarly, the mole ratio must also be equals to mole fraction ratio. That is, Na is to Nb, mole ratio equals to Xa is to Xb, mole fraction ratio. It can be dot means it can be extended also, not only A and B, A, B, C, D, E, F, G, H like that. Proof. For result number 1, Xa plus Xb plus dot is equal to, we can say what? Na by Na plus Nb plus dot plus Nb by this plus go on. So ultimately if we add, what will happen? Na plus Nb plus dot by Na plus Nb plus this equals to 1. Result number 1. Similarly you see Na is to Nb dot equals to, we can say what? Na by total number of moles of mixture is to Nb by total number of moles of the mixture is to dot. Yes, so this is equals to what? Mole fraction Xa is to, this is equals to what? Mole fraction of B, Xb dot. Result number 2. Now you see sample problem. A gaseous mixture contains non-reacting gases A and B with their masses Ma and Mb respectively, and their molar masses are given capital Ma and capital Mb. So we have to find their mole fractions. So you see amount of A, that is called Na, equals to what? Mass by molar mass by dimension. Think with dimension. Mass means gram and molar mass means gram per mole. So ultimately we will have a number of moles. So Na equals to what? M, small m by capital M means gram by gram per mole. So ultimately mole. So it is the formula of what? Na, that is the amount or number of moles of A equals to mass of A divided by its molar mass. Similarly, amount of B equals to what? Yes, mass of B divided by its molar mass. Now we are finding the mole fraction of A. So mole fraction of A, Xa equals to what? By definition, Na by Na plus Nb. This implies Xa equals to what? The Na? Ma by Ma, small ma by capital Ma divided by small ma by capital Ma plus small mb by capital MB. Multiply numerator denominator by capital MA into capital MB. So you will have this one. answer. Now finding mole fraction of B. First method just like this, or another concept also, result 2. Let us see. First method, mole fraction of this. So XB is equal to NB by NA plus NB. So similarly, NB replaced by small mb by capital MB. Similarly, this. So ultimately, we will have the result multiplying numerator denominator by capital M, capital MB. Or second method, you see, we know mole fraction of B equals to 1 minus mole fraction of A, because only two non-reacting gases. So mole fraction of A plus mole fraction of B equals to 1. So mole fraction of B equals to 1 minus XA. Put the value and ultimately you will have this answer. Now next problem. 1 liter aqueous solution of acetic acid. It is a formula CH3COOH contains 2 mole of acetic acid. The density of the solution given 1.02 gram per milliliter. We have to compute the mole fractions of acetic acid and water. Solution. Mass of acetic acid in 1 liter solution equals to, already given 2 mole. So convert 2 mole into 2 mole in gram. How? 2 mole. The molar mass of acetic acid is 2C, 4H and 2O. It will be 60 gram per mole. Yes, you see, if I say relative molecular mass 60 U per molecule, be careful. If I say molar mass 60 U becoming gram, one molecule becoming 1 mole, be careful. So 60 gram per mole. So multiply it. Because factor level concept, 1 mole 60 gram per mole. So mole cancel, 120 gram acetic acid. It is the mass of acetic acid in 1 liter solution. Now let us consider. Let us find the mass of 1 liter solution. How? Density of the solution is given. So mass of 1 liter, that is 1000 ml solution equals to what? 1000 ml, and you see density 1.02 gram per ml. Factor level ml cancel, you will have a gram. 1020 gram solution. So what is the mass of solvent water? 1020 gram solution minus 120 gram acid. So we will have 900 gram water. Now we will find the amount of water. 900 gram water. You know molar mass of water 18 gram per mole. So we need mole. So mole will appear in the numerator. We have to cancel gram. 18 gram will appear in the denominator. So 50 mole water. Then mole fraction of the acid is equal to what? Already acid, amount of acid is 2 mole, and total number of mole of solvent and acid 50 mole water plus 2 mole acid. So 2 mole acid by 52 mole solution. So if you calculate 0.038 mole acid per mole solution. Again you see, if you see book, they have simply written 0.038, no dimension. A mole cancel. Fact is not like that. In factor level you see mole acid and mole solution, it cannot be cancelled out. So mole acid, casually you can see mole and mole, but fact is not like the mole acid, it is mole solution. So to apply factor level concept, remember the mole fraction also has dimension in our factor level concept. So it will be mole acid per mole solution. This is the answer. Casually you can say 0.038, no problem. But truly speaking, it is mole acid per mole solution. It clearly indicates what? 1 mole solution contain 0.038 mole acid. Be careful. Now what is the water? 1 minus, because mole fraction of acid plus mole fraction of water equals to 1, you know. So mole fraction of water equals to 1 minus mole fraction of acid. Hence the result. SP03. We have to compute the mass of NH4Cl that is required to dissolve in 100 gram water. We require the mass of NH4Cl to be dissolved in 100 gram water to prepare a solution with a mole fraction of 0.15 for NH4Cl. The solution will have the mole fraction of NH4Cl as 0.15. Now solution. Already we have explained, you see, mole ratio equals to mole fraction ratio. Already you see equation number equation 053. Mole ratio is equal to mole fraction ratio. So this implies mole ratio. N implies mole, number of moles. So number of moles of NH4Cl is 2. number of mole of water equals to mole fraction ratio. Mole fraction of NH4Cl 0.15. So what about water? 1 minus 0.15, that is 0.85. So required mass of NH4Cl. You see, we are going to find the what NH4Cl in 100 gram water. So 100 gram water, first you convert water into mole. So 18 gram water, 1 mole water. So gram water cancel mole water. Now come here, you see, it clearly telling us what? 0.85 mole water. 0.5 in the required solution. 0.85 gram water contains 0.15 mole NH4Cl. That I have used here. 0.85 mole water. Yes, it contains 0.15 mole NH4Cl. So mole water cancel out. We have obtained the mole NH4Cl. Now convert to gram NH4Cl. We know 1 mole NH4Cl, molar mass of NH4Cl is what? 53.5 gram, because nitrogen 14, hydrogen 1 and chlorine 35.5. So molar mass of NH4Cl is what? Molar mass of NH4Cl is what? 53.5 gram per 53.5 gram 1 mole NH4Cl. So ultimately we will have 52.45 gram NH4Cl. Gram water cancel out, mole water cancel out, mole NH4Cl, mole NH4Cl cancel out. We will have gram NH4Cl. Now, next problem 14. 1 mole of the mixture of ethane, it is a molecular formula, and ethene, it is a molecular formula, reacts completely, be careful, trace on completely, with 104 gram of oxygen to produce carbon dioxide and water, assuming the ideal gas behavior. Yes, compute the mole fractions of C2H6 and C2H4 in the mixture. Now let us, based on reaction. So first let us consider the what? Combustion reaction. Reaction with oxygen means combustion reaction. So C2H6 ethane plus O2 producing carbon dioxide and water. If we balance, make it 1 mole, it will be convenient for calculation. So carbon 2 is set here, hydrogen 6, so 3 is set here. So hydrogen 6, carbon adjusted. Now adjust oxygen. Is oxygen molecule, how many atoms? 7 by 2 oxygen molecule. First you see here, how many atoms? 4 atoms oxygen plus 3 atoms, 7 atom oxygen. Because here it is an atom, that's why we are counting in terms of atom. Otherwise we can count in terms of molecule also. But here 3 atom. So actually here 4 atoms, 7 atom. Come here. The molecule O2. 1 molecule means 2 atoms. So 7 by 2 molecules. 7 by 2 into 2 atoms is equal to 7 atoms. 7 atoms adjusted. C2H4 is very simple. 3O2, this is a reaction. Let N be the amount of C2H6 in the mixture. So what is the amount of O2 reacted? Please you see 1 mole requires 7 by 2 mole. So N mole require 1 mole requires 7 by 2 mole. So N mole require 7 by 2 N plus. In case of the C2H4, 1 mole require 3 mole oxygen. So it will be what? 1 mole, my total number of mole of the mixture is 1 mole, be careful. So N is the number of mole of C2H6. So what is the number of mole of C2H4? C2H4 1 mole minus N. C2H6 and C2H4 1 mole. We have considered C2H6 N mole. So what is C2H4? Yes, 1 mole minus N. So 1 mole required 3 mole oxygen. So 1 mole minus N required 3 mole oxygen 3. You see, known quantity appears with dimension. Unknown quantity is left as it is. And finally the unknown quantity will appear with dimension, you see. So N, we don't know what the dimension. So simply N I have written. But 1 mole, we know 1 mole is the amount of the mixture. That's why. So you see, C2H4 is what? 1 mole minus N. Now 1 mole required 3 mole. So 1 mole minus N required 3 mole oxygen. So it is the total amount of oxygen reacted. Now then you see the given condition yield 3 by 2 N plus 3 into 1 mole minus N equals to what? Already given you see in the problem. It requires 104 gram oxygen. So convert to mole, 104 gram oxygen, and you know 1 mole oxygen, 32 gram oxygen. Gram oxygen cancel out. We will have a mole oxygen, that is 3.25 mole. So this equals to, you see, half n actually, your 0.25 mole. So n is equal to 0.50 mole. So now we can calculate the mole fraction. Mole fraction of C2H6, 0.5 mole C2H6 by 1 mole mixture. So 0.50 mole C2H6 per mole mixture, or simply you can say 0.50. Similarly, the mole fraction of C2H4, 1 minus C2H6. So 1.00 minus 0.50 is equal to 0.50 mole C2H4 per mole mixture, or simply 0.50.